this slide shows you how to determine the concrete cover. Cover is a distance between the surface of the reinforcement closest to the nearest concrete surface. As you can see in the picture, the far right column, the concrete covers, the reinforcement is covered by the concrete, while on the left, it's exposed. Basically, covers is to protect the steel against corrosion, the safe transmission of bond forces, and also to provide adequate fire resistance. Concrete cover is also called nominal cover, which is based on the minimum cover from the three following parameters. The first one is minimum cover due to bond. Second one, minimum cover due to durability. And lastly, minimum cover due to fire resistance. As shown in the picture, it means that C norm is from the surface of the concrete to the surface of the shearing. In construction, the required nominal cover can be achieved by putting the spaces between the formwork and the link before the concrete pour. Here is example a beam that supports the roof of a monumental building with a design working life 100 years. So what is the nominal cover that we need to use? Cover is normally determined in the first stage of design, so that we don't know yet the steel size. I mean the compressions and also the flexural reinforcement. We don't know the diameter, exactly the diameter. So in this case, we just can assume it. So let us assume that the flexural diameter is 25 mm, while the link is 10 mm. In order to obtain the nominal cover, we did two steps. The first step is to determine what is the C mean for each parameters, for bond, for durability, and also for the fire resistance. And then of these three, we select the biggest one and use for the C nominal. Okay, let's start first with the determination of C mean due to the bond. It can be seen that the tensile reinforcement will be positioned in the single or separated ways. So here we select the separated, which means the C mean will equal with the diameter of the bar. The second step is to determine the C mean due to durability. So in this case, according to the questions, the beam will be placed inside the building. So in Eurocode, it can be said it is dry conditions and either low or high humidity. This diagram shows that in Eurocode, the durability of the elements can be divided into several cases. It depends on the position where it is located. For example, if the beam inside the buildings, so it will have a high or low humidity. Other than that, for example, in a foundation, it is exposed to water or groundwater, so it has different durability cases. The exposure classes can be obtained in Table 4.1 Eurocode. It shows that a lot of different cases. For example, XC means exposure to decarbonation, and XD means exposure to the chlorides. We need to establish the exposure condition of the beam. Let's say it is XC1. We establish the durability cases. The next step is by referring to table F.2, where we can find the concrete classes. We can see that the minimum grade of concrete is C20/25. Step is the determination of the structural class from table 3.4.3n. From here, our assumption is that the structural class is default S4. Then from here, since it is will be designed for 100 years, so we need to go to the XC1 column with a row design of 100 years. So the structural class must be increased by 2. Further, the structural class will not be modified for the concrete strength, the member related with the slab, and also the quality control. Therefore, our structural class now is S6. Finally, from the structural class that we obtain, we get the cover for the XC1 that is 25 mm. This value is obtained from the table 4.1 Eurocode as shown in the picture. The semen from the fire resistance, we can refer to the table 5.5 where we can get ASD. ASD is equal A plus 10 mm, where A value can get from table 5.5. Once we get the ASD, we will calculate the semen. ASD can be determined according to the fire resistance. In this example, the fire resistance is 60 and B is 250. So the value of A can be obtained from the interpolation between 200 and 300B, or we just use 200, so it results A is equal 30. The relationship of A with the semen, diameter length, and also diameter of the bar can be seen in the picture. And by replacing ASD into this equation, we have another expression, semen is equal ASD plus pi length minus diameter bar divided by 2. From this equation, we get the semen due to fire resistance. We already have semen due to bonding, due to durability, and due to fire resistance. Of these three, the biggest value will be selected to have the C norm by including the deviation of the cover equal with 10, so we get the new value 35 mm.